Hello and welcome to video 25 in my Rigging in Maya series. We are now on the last part of this mini series of videos where we look into creating an automatic limb rigging tool. There are other areas of scripting I'd like to cover, but I will look into those in future videos. All we are going to do in this video is add volume preservation, which will enhance the overall look of the stretchy limbs. Now this isn't strictly something that's needed for this character, but then again neither are stretchy limbs, but I thought I would include it in the script so you can use it on other characters and creatures you might rig in the future. Before we get started, I wanted to mention that you can now download all the source files for this and all my other courses from my Cube Brush, Coffee, Gumroad and ArtStation pages. You can find links on the screen and in the description below. I also wanted to tell you about the antCGi Club. Joining the club is a way for you to help support the future of this channel, as it will allow me to dedicate more time to creating new content just for you. But that's not all. You can also earn yourself exclusive rewards. These include all the course assets, models, rigs and custom made scripts, as well as access to the members only area of the antCGi Club Discord server. What's more, you can also claim a discount on all antCGi merchandise. Now there are two ways you can join. The first is to simply click the join button below this video and become a member of this YouTube channel. The second is to head over to my Patreon page and support me there. Alternatively, you can visit the link on the screen or in the description below to find out more. So first, what is volume preservation? So here we have two cylinders. They are both identical. If I squash the first one, we get quite a linear movement. It's obviously stretching, it's getting longer and shorter, but that's all. And this is where we are at with our stretchy limbs. If we look at the second cylinder now, as I push and pull it, it expands and contracts. This is because it's trying to maintain the overall volume of the cylinder. So this is more realistic, kind of like if it was full of water. The volume of the water remains the same, so the shape of the cylinder has to change to take into account the forces being applied to it. This is the effect we're going to add into our rig, and don't worry, we've already done all the hard work, so it's quite a simple task. Okay, here we are back with our dog rig, and remember that this only has the controls. So there are currently no systems in the scene. If I open the script editor, although this is Charcoal Editor, just a plugin that I use, we can see the script we've created so far. To run it, we just use this button here. So I select the root joint and run the script. I'll just make the systems visible. And that's the leg rigged for us. We can see the roll joints and the leg is stretchy too. So what we need to do is add volume preservation into the middle joints, so they essentially get thinner the more we stretch the leg. Okay, so let's build this manually first so you can see how it's added. We will then add it to the script later. I'll just bring the outliner over. What I need to find is the blend colors node. Here it is. This is the one we added to control the stretchiness, so essentially switch it on and off. I'll just open the node editor and graph that. We don't need to see these. Or these. So here we have the two main length nodes, one for the length of the leg and the other checks how far the control is away from the root of the leg. These both go into our scale factor node and then into the blend colors node just so we can switch it on and off. This is then connected to the condition node, which allows us to check when the leg should stretch and in what way. The key to this is adding the volume preservation in the right place, so it only triggers when the leg is stretching. So we need the blend colours and condition nodes, as they are the main controllers. I'll just open these up. First we need a multiply divide node. Oops, just bring everything back. Let's rename this, and let's call it volume. If we check the scale factor node, which is also a multiply divide node, we can see it is set to divide. But with our volume node, we need to set the operation to power. Now this is quite important. What power does is basically take the input 1 value and multiply it by itself, the amount of times specified in the input 2 value. If we set input 2 to 0.5, what this will give us is the square root of input 1, which is what we need in this instant. What this will do is give us a more gradual and predictable value to use to scale our limbs. Let's now take the stretch value from the blend colours node, so output R, and connect it to the input 1x attribute on the volume node. So this is now going to multiply the scale factor by itself 0.5 times. We now need to take the output and pipe this into the condition node. So take output X and connect it to colour if true G. We're using G because R is already being used to calculate the length of the leg when it stretches. We can use the next set of attributes, so this will affect the leg volume too, but only when the stretch is enabled, which is what the condition node checks for. If you want different values on each joint, so let's say you wanted one joint to be compressed more than the other, you could use the other attribute on the condition node to control them separately. What you would do in this instant is use a different set of attributes on the volume and condition nodes. So input 1y for example, and then pipe the output y attribute into the condition node's colour if true b attribute instead. Now don't worry, I will be covering this in future videos, so don't worry if you don't completely understand what I'm talking about. Okay, let's bring the joints in now so we can connect those up. We don't actually want the IK joints, so I'll hide the systems again. That's better. So let's open these up. So scale X is already being used to change the length of the leg. So we want to connect to scale Y and Z to affect the volume. To do this, we need the outColorG attribute. Remember that the volume values are being used by the green channel, not red. Let's connect that to the fibula. And also the metatarsus. Again, if we wanted to have different values on the metatarsus, we would use the outColorB channel instead and connect that to the scale attributes. If I adjust this now, you can see that the volume is changing. The leg is getting wider. But we need it to get thinner. All we need to do is change the input to X attribute on the volume node. Inverting it, so setting it to minus 0.5 should do the trick. There we go, we can see that's worked. And the volume is now maintained as we stretch the leg. What we can also do now is give the animator a little bit more control over the volume. If I select the main leg control, you can see I have a volume offset attribute here. We can use this to control how the leg scales. Let's bring that control in. All we need to do is connect volume offset here to the input 2x attribute, the one we just changed on the volume node. I'll update that so it's a minus value. So I can now stretch the leg and use this attribute to adjust how wide or narrow it is. What's good about this setup is if that leg isn't stretching, the volume won't be affected. It only works if it's stretching or being squashed. If I change this to full, so the leg will squash now, we get the volume control back. Okay, great. So that's how to set up volume preservation. Again, make sure you refer back to my previous video on adding squash and stretch, as you need to make that first. If you had more joints in your setup, you could vary the amount the volume changes on each by adding more volume and condition nodes, but like I said earlier, we will cover that when we come to rig the spine and the tail. Okay, that's been added manually, so now let's include it in our script. So let's open the script editor. So we could add this to the end, as we have been doing with each section of this script. But because this is an extension of the stretchy limb code, it makes sense to include that after it. So let's copy this. And paste it here, before the roll joint code. And update the comment. So first we need the multiply divide node, which will work out the volume for us. We want the shading node command, so let's copy this to start us off. And change the node type to multiply divide. And we will change the name to volume. Now we have that node, we need to connect it to the main stretch value, as we did before. So this will connect to the blend colors node. Change this into a comment. We now need the connect atta command, or the connect attribute command. Again, I'm copying code from earlier. It's not cheating, honest. This works because it has the exact attribute we need, so we don't need to change this. Let's update what it's connected to. So it's the volume node. And we're connecting to the input 1x attribute. Now we need to connect from this to the condition node. So this time we need the volume node first. And its output x attribute. And we are going into the condition node. And we want the color if true G attribute this time. So we are just following the exact steps we did when we built this manually before. Now we have this set up, we can start to connect to the joints. One thing I do need to point out is we will need to update this later in the series. What we will need is for this to connect to the joints which are built as part of the ribbon, because it's those that will drive the model, not these driver joints. Like I said in an earlier video, I basically skinned these joints just temporarily, just to help out with this script. So just wanted to make you aware. You basically connect the condition node to the skinned joints. First we want the fibula joint here. So we are coming out of the condition node, using the outColor G attribute, Now we need to reference the fibula joint. So let's use the joint hierarchy list. As this is the second joint, remember the numbering goes 0, 1. We need to put 1 in brackets. And all we want is the scale y attribute. Let's copy this. And we just want to do the same, but this time connect to the scale z attribute. That's the fibula connected. Now we do the same for the metatarsus. This is the next joint in the list, so all we need to do is add 1 to its value, making it 2. And finally, let's connect that volume offset attribute so the animator has more control. Let's adjust it first so we can see the MEL script. So this is the attribute we need. Let's copy this. What we need is the name of the main control, because that's what the attribute is on. And we set this earlier in the project, right at the start of the script. Here we go, main control. So, change this here, and we need the volume offset attribute. We can also remove this because it isn't part of the name. This needs to drive the volume's input2x attribute, so I can copy this and change 1 to 2. Okay, that's the control connected. I think that's everything, but it's worth giving this a try now. Okay, no errors, so that's a good sign. So I'll enable stretchiness. Okay, this doesn't look right. We must have missed something. Let's check the nodes. So volume has the right connections. Blend colours looks okay. Let's have a closer look at the volume node. There we go. This should be set to power, so we missed that in the script. So in theory, if I change this now, we get the MEL command, so that's useful. But yeah, the leg looks better. Okay, let's add this in. So we just need a set atta command. I'll just copy this one. Let's update the name. Actually, we can just grab all this because we want to update the volume node. And add the operation attribute to the end. Now we set this to 3 to change it to power. Okay, that should fix it. Let's undo everything and try it again. Okay, update stretchiness again. And move the paw control. There we go, much better. We have a stretchy limb with volume preservation. Just reset this back to minus 0.5. And reset the paw. I'll just update all the volume offset attributes so they're the same. Currently they are 0.5. Right, with that done, let's now rig the other legs. So that's the right side done. I need to remember to update the script to rig the front legs. So change this to 0, and now we can rig the front legs. So that's left, and that's the right one. Now I'll select all the paw controls and make sure stretchiness is on. Right, let's see if they all work. Great, all stretchy, and they get thinner the more we stretch them. Let's hide the controls and the joints so we can just see the model. Okay, so there we go. Over the last 5 videos, I've taken you through the process of building your own automatic limb rigging tool, and while doing so, introducing you to using Python. Now this is just basic, but I hope it's been useful to you all. Obviously, we could go so much further with this tool. The script we created could do with some optimization. We could add more functions so each section can be easily called or ignored. We could even build a UI, but I might leave that and add it as a CG tip video. What do you think? One other area you could explore is control creation. So you would just need the joints to start off with and the script would build all the controls for you. If you were feeling brave, you could even use this as a base for your own modular rigging tool, but I'm getting way ahead of myself there. I'm not opening that can of worms. Not yet anyway. Okay, so at this stage we have all 4 of the dog's legs rigged. So I think we will leave scripting here, and in the next video we will start to add the ribbons which these joints will drive. Well, we've come to the end of another video. Thanks for watching right to the end, and if you found this video useful, please hit that like button to show your support. While you're at it, you could also subscribe and enable notifications so you're kept up to date with future videos and community posts. If you have any questions or suggestions, please post them in the comments below or contact me through the antCGi Club Twitter account and I will try my best to reply. Alternatively, you could post them in the antCGi Club Discord server where I spend more of my time. You can find an exclusive invitation to join in the description below. Remember that you can also join the antCGi Club to help support future videos while also earning exclusive rewards. Alternatively, if you would just like to show your appreciation, why not treat me to a coffee at my coffee page? The link is on the screen now and in the description below. Thanks again, this is antCGi signing off and I will see you on the next one.